Welcome to today's explainer. So, if you're on the hunt for a good C++ while loop tutorial, or you're really just trying to wrap your head around loops in C++ for beginners, well, you've landed in the absolute right place. But look, before we can write a functioning while loop in C++, we really need to master the bedrock of the language first, especially control flow statements in C++. A lot of people think programming is this scary, incomprehensible alien language, but it's not. It is literally just your everyday, real-world logic translated into code. So let's demystify the whole shebang together.
Now, you might be wondering, why even focus on C++ right now with all the new AI trends out there? Well, understanding C++ is still an absolute foundational must-have for tech careers. I mean, think about massive, real-world applications. Take Zomato, for example. In their system, the delivery partners, the restaurants, the menus, the users, these are all treated as objects. And C++ is the powerhouse that lets engineers build those complex, high-performance systems. Once you understand the underlying logic here, you can build practically anything. All right, here's our roadmap for today. We're going to start with the foundation of C++, then we'll dive into variables, constants, and scope. After that, we'll check out our coding tools, the operators, figure out precedence rules, and finally, we'll tackle control flow decisions.
Okay, let's jump right into Section 1, the foundation of C++, understanding the why.
Moving right along to Section 2, variables, constants, and scope. Let's talk about storing data. Think of a standard variable like an everyday school bag. You can swap out a laptop for a water bottle whenever you need to. But what if you absolutely don't want the contents to change? That brings us to a constant. Imagine literally sealing that school bag with a heavy padlock. Once you assign a value to a constant, it gets a massive do not touch stamp. This is absolutely crucial for fixed real-world values in your code, like the speed of light for a physics engine, or pi for a math calculation. You just declare it once, and it stays safe forever. We also really have to consider scope. Basically, this is the territory your data is actually allowed to exist in. Think of a local variable as someone who is only famous in their specific neighborhood. Outside that one block, nobody knows who they are. And crucially, if you don't assign a value to a local variable, the computer just gives it random garbage values. Seriously, it's just junk data. A global variable, on the other hand, is known nationally. It gets declared right at the top, and the entire program knows it. And if you forget to assign a value here, the system is pretty nice about it and politely defaults it to 0. Which brings us to Section 3, operators, our coding tools. Picture a grocery store checkout counter. You're scanning items to tally prices, maybe applying a discount, or removing an item you changed your mind about. That constant adding, equating, and comparing, that's exactly what operators do in code. We've got arithmetic operators for basic math, relational operators to ask things like, hey, is this heavier than that? We use logical operators to combine conditions. Bitwise operators go deep into the actual memory bits. And finally, assignment operators are what you use to actually store your final calculation back into that school bag we talked about. Now, here is a very specific trick with arithmetic operators that trips up a lot of beginners: pre-increment versus post-increment. Pre-increment, which is written as plus plus a, is proactive. It adds 1 to the value immediately, and then uses that brand new value in the code. Post-increment, written as a++, is a bit lazier. It uses the current value for whatever operation it's doing right now, and only bothers to update the value afterward. Knowing the difference is a real game changer. Next up is Section 4, operator precedence rules. So when you cram multiple operators into a single line of code, the computer doesn't just guess what to do. Just like the BODMAS rule you learned in grade school math, C++ has a strict priority list. The highest precedence goes to those postfix operations. They always get handled first. Then comes prefix and logical knots. Down at level 3, we see familiar math: multiplication, division, and modulo, which just gives you the remainder. Addition and subtraction set at level 4. And the very last thing the computer does, assignment. You have to solve all the complex math first before you assign the final answer. But wait, what happens if you have a tie? Say you've got a multiply and a divide right next to each other in the exact same expression. That brings us to associativity, the tiebreaker rule. Almost all the time, C++ breaks the tie by reading left to right, just like you're reading a book. But keep your eyes peeled for a few rare right-to-left exceptions, primarily with those prefix increments and assignment operators.
All right, finally, let's dive into Section 5, control flow and decisions. Up until now, our code just ran straight down, line by line, but control flow gives our program the intelligence to actually evaluate data and make choices. Think of that classic parent promise. If you get more than 80% marks, you get a bicycle, else you don't. This is the exact logic of the if-else statement. If the if condition evaluates to true, boom, you enter that block of code and get the bike. If it's false, the program completely ignores that block, jumps straight down to the alternative else block, and executes that instead. And, this same true or false condition check is the core of loops too. For instance, in a while loop, you initialize a variable outside, set your condition in the parentheses, and put your updation step inside the loop body. The code just keeps executing over and over as long as that entry condition remains true.
But life isn't always just two simple options, right? Sometimes we have multiple cascading scenarios. That is where else if comes into play. Imagine you're grading a paper. Step 1. If the score is above 80%, print grade A. Step 2. If that was false, well, check the else if condition. Is it above 60%? If true, print grade B. Step 3. If all of those fail, just fall back to the default else block and print grade C. Your software is basically filtering data through multiple specific scenarios until it finds the perfect fit. And what if you need to repeat a scenario where the number of iterations is completely unknown? Well, that's exactly when you'd swap to a while loop instead of a standard for loop. Think of an ATM checking your PIN. The condition basically says, while the input is not equal to 9999, keep asking. You might guess it on try 1 or try 50. The loop just endlessly repeats until that inequality condition evaluates to false. It's incredibly powerful. To wrap up today's explainer, I want to leave you with a bit of a brain teaser. Remember those rare operators we talked about that use right-to-left association? Well, assignment operators are one of them. So if variables A, B, and C all start at exactly 10, and you run the compound assignment A plus equals B plus equals C, what is the exact final value of A? Think really carefully about which part of that equation gets solved first. Drop your answers below and keep practicing this logic. What will you build with it first? Thanks for joining us, and we'll see you next time.